AB, free response 5. Let f be the function defined by f of x equals e to the x cosine x. Part A, find the average rate of change of f on the interval from 0 to pi. So average rate of change just means old school slope, right? So what we want is f of pi minus f of 0 over pi minus 0, right? So that's going to be e to the pi cosine of pi minus e to the 0 cosine of 0 all over a pi minus 0, right? So I'm going to get that that's a negative e to the pi minus a 1 all over a pi, right? And that mostly just involves knowing your unit circle and knowing what average rate of change means. Part B, what is the slope of the line tangent to the graph of f at x equals 3 pi over 2? Okay, so slope of a tangent line, right? Slope of a tangent line means find the derivative and plug in that x value. So we need to find f prime of x. So f prime is going to involve using a product rule, right? Because we have e to the x times cosine. That is a product of two functions of x that cannot be simplified. So u dv, derivative of sine or of cosine is negative sine, right? Plus v cosine of x. Du, derivative of e to the x is e to the x, right? You can simplify it if you want, but since they specifically only wanted f prime at a particular point, there's not a whole lot of reason to simplify it. So when I plug in, I'm going to get e to the 3 pi over 2 times a negative sine of 3 pi over 2, right? Plus a bunch of 0, because cosine of 3 pi over 2 is 0, right? And if it helps to picture it, so 3 pi over 2 is right here, right? That's the point 0 comma negative 1. So this is going to end up being an e to the 3 pi over 2 times a negative of a negative 1, which is just a 1. So my answer is that f prime of 3 pi over 2 is an e to the 3 pi over 2. Right? That's my answer for my tangent slope. Right? And you should double check that they only wanted the slope of the tangent line, and that's the only one they wanted. So this is the slope of that tangent line, right? The tangent line when x is 3 pi over 2. Cool. And here you got 1 point for finding the derivative and 1 point for plugging in to get the value. Part C, find the absolute minimum value of f on the interval from 0 to 2 pi and justify your answer. Okay, so the trick here is that to find the absolute minimum, I'm going to find all the critical points on the window from 0 to 2 pi, and then I'm just going to figure out which one of them is the lowest, right? That's the easiest option. So this is part C, right? So if I want the absolute minimum of f of x, I need critical points, right? The critical points happen in 3 places. First part, where f prime is 0. Second kind, where f prime doesn't exist, and that's not going to happen here because e to the x and sine and cosine are all nice, happy functions. They don't have any domain restrictions, so that's not going to happen. And the other kind of place is at an endpoint, right? And the endpoints that I was given were 0 and 2 pi, right? So x is 0 and 2 pi are my two endpoints. So I need to know when f prime is 0. So I'm going to go ahead and set negative e to the x sine x plus cosine, plus e to the x cosine x equal to 0, right? First thing I would suggest you do is factor out an e to the x or a negative e to the x. It doesn't really matter. So factor out a negative e to the x, and I get sine x minus cosine x equals 0. I know that negative e to the x can't equal 0. E to the x is a positive number, so this is saying that a negative is 0, and that's a lie. Forever and always, it's a lie. So I know that the only possible critical points are when sine minus cosine is 0, so that's when sine of x is equal to cosine of x, which is saying when the y on the unit circle is equal to the x on the unit circle, and that only happens here in quadrant 1 at pi over 4, and here in quadrant 3 at 5 pi over 4. So I now have my other two critical points. My other two critical points are pi over 4 and 5 pi over 4. So now the easiest thing I can do is just plug in those 4 values and see which one comes out physically lowest. So I'm plugging into the original, not the derivative. So my critical numbers, right, there's no point in making a sign chart. I just want to find out which one's the lowest, so I might as well plug in. So my critical numbers, right, so my critical x's, right, were 0 and pi over 4 and 5 pi over 4 and 2 pi, right? And I want to know which one has the absolute lowest value. So I'm going to plug in. So when we plug in 0, right, we get e to the 0 times a cosine of 0, which is a 1. So I just get an e to the 0, which is a 1, right? Great, cool. when I plug in pi over 4, I get e to the pi over 4 times a root 2 over 2. And I'm going to leave it like that and figure it out in a second. When I plug in, because again, pi over 4 is right here, right? When I plug in 5 pi over 4, I get e to the 5 pi over 4 times a negative root 2 over 2. Well, right away, this is a positive number, and this is also a positive number, and this guy's a negative number. So these guys are not contenders for the lowest possible value. Nope, nope, because they're positive numbers, and this guy is a negative number, so there you have it. And then for the last one, right, because again, that was 5 pi over 4, which was here, right? I'm going to get e to the 2 pi times a cosine of 2 pi, which is also a 1. So this is an e to the 2 pi, which again, to be clear, is a positive number. So just based on the fact that this is the only negative number, it has to be the absolute min. If there had been a situation where I had two negative numbers, I would have to figure out physically which one's larger without a calculator, which can be a little bit tricky, but you would have to sort of approximate and figure it out. Anyway, so the absolute minimum, so the absolute min is negative root 2 over 2 e to the 5 pi over 4. Now they asked, what is the absolute minimum value, and that's my minimum. If they had asked when it happened, I would say at 5 pi over 4. Cool. Part D gives me a graph. So part D, let g be a differentiable function such that g of pi over 2 is 0, and the graph of g prime, the derivative of g, is shown below. Find the value of the limit as x approaches pi over 2 for f of x over g of x, or state that doesn't exist and explain why. Okay, so I'm going to do a really terrible job of recreating this graph for just a second. What seems to be important here is that at pi over 2, the g graph does something like this. Okay, so this is the g prime graph. Cool. Okay, so we want the limit as x approaches pi over 2 of f of x over g of x. So first thing we should do naturally is plug in. So this is e to the pi over 2 times a 0. And we were told that g of pi over 2 is also a 0. So I get 0 over 0, right? This is not ever the answer. So this is not ever the answer. But it does mean that we are okay to do L'Hopital's, right? So we're okay to do L'Hopital's, because when we get an indeterminate form like 0 over 0 or infinity over infinity, we're okay to do L'Hopital's. So I can say that this is equal to the limit as x approaches pi over 2 of f prime of x over g prime of x, right? Well, I can see physically that g prime of pi over 2 is a 2. So this is a 2, and I can find f prime of pi over 2 by plugging in the value to the f prime that I had. Now, unfortunately, I erased my f prime, and, you know, on a real problem, you would still have your f prime. But my f prime of pi over 2 would have been a negative e to the pi over 2 times a sine of pi over 2, which is a 1, plus an e to the pi over 2 times a 0. So I get that this is a negative e to the pi over 2, if I remember correctly. And so that's the value of the limit. I did L'Hopital's once, and I was able to get the values because this was the y value given on the graph, right? This is g prime. G prime of pi over 2 is a 2. And f prime we were able to find from using the formula that we had earlier that I erased because it's not on a piece of paper.